Hi guys, my name is Abdulrahman. Today we'll be talking about stacks and queues. What are stacks and queues? A stack or a queue is a logical data structure with an established order in the way the elements behave inside the collection. They use a set of principles to determine how data are inserted or removed from. Stack uses the principle last in first out and queue uses the principle first in first out. You can use an array or a linked list as a storage structure to implement the stack or queue pattern. You can even create more complex patterns like binary trees and priority queue with these basic structures. First, we'll talk about queues. As I mentioned before, queue uses the first in, first out principle. What is first in, first out principle? Well, first in, first out means that the data entered first will be the data to be removed first. Now, let's take a look at how we can implement a queue using an array. Alright, so we are going to see how we can enter data into this array as a queue. So in a queue, the logic is that the data will be entered through the rear point, and when it's being removed, it will be removed from the front. So let's say we want to add the data 5, 4, 3, 2 and 1. How will we enter? So first we'll be entering 5 through the rear. So the rear will be going here and it will be stored here. 5 will be stored here. Then 4 will be stored here, 2 and 1. So now let's say we want to remove off 5. So how do we remove? In an array you normally have a for loop and you run through and search where the 5 is and you remove. But in this case you cannot remove like that. You need to remove from the front pointer. So in this case, this point. So you'll be removing data from this point. So 5 will be taken off and all the other elements will be moved forward. And the empty value will be initialized with a 0. Alright. When you add elements into the queue, you have to increment the rear value. So you can say rear when you add data into the queue, the rear value will be incremented, and when you remove from a queue, the front value will be incremented. Alright, okay. Now let's take a look at our left side, where I'll be showing you the code on how to add to a queue, remove from a queue, and show the queue. There are two main methods actually in inserting to a queue and removing from the queue. The insertion and the reinsertion is usually called as enqueue, and the removing is all usually called as dequeue. And we can implement two additional methods called size and isEmpty. So if you would take a look onto your left, I have two classes. I have two classes. One as the main class, where I'll be adding and passing the parameters into the queue class. So in the queue class, I have a method called enqueue, that is to add to the data. And inside that, I'm checking if the queue is full. If the queue is full, then I'm printing an error message, and if it's not full, I'm adding the data into the queue. And in dequeue, I'm doing the same thing, but in this case, I'm checking if the queue is empty. And if the queue is empty, the error message is displayed queue empty. And I'm incrementing the front and decreasing the size. Show is just a basic for loop where I print the values in the queue using the for loop. Get size will just return you the size of the queue. So now if you were to go to the main class, and you see I have added 5 elements, 5 data into the queue. So let us run this code and see how it works. Okay, as you can see in the start, I check if the queue is empty, just to show you all how isEmpty works. So initially the queue is empty, so it will give a boolean value of true because it says is empty. And next I'm checking the size by saying get size. So currently the queue is empty, so the size will be 0. There are 0 elements. Next I'm adding 5 elements, 5, 4, 3, 2, 1, and I'm displaying the queue. As you can see, I have successfully added the elements, and then I'm checking if the queue is empty and queue is full, like the size of the queue. As you can see, empty comes out false and size is 5. Now I'm removing 2 elements, dequeue 2 elements. So when I dequeue 2 elements, what happens is the first 2 elements, 5 and 4 in this case, is removed, and 3, 2, 1 is displayed.
As you can see, the size is also decreased compared to the earlier size of 5. Then I'm adding another 3 more elements. As our queue size is 5 and can only contain 5 elements, and I'm trying to add more than 5, yeah? So it will add the value 10 and 11, as you can see, and it will display an error message saying queue is full. And that's it for queue. Now we'll take a look at stacks. Just comment this one out. Alright. Okay. Stacks uses the method, the principle last in, first out, meaning the last value to be entered into the stack will be the value to be removed from the stack first. Alright. Now So I have a class called stack where I'll be doing the addition to the stack, removing from the stack, and peek and show. Peek is the same as removing from a stack, but you don't remove the value from the stack, you just take a look at what the value is. And show displays the stack using a for loop. Size gives you the size of the array, size of the stack, the number of elements in the stack, and this empty will tell you if the stack is full or not. Commonly, adding to a stack is known as push, and removing from a stack is called pop. So unlike in queue, we only have one additional variable called top. So what you do is, in this case we are going to look at a fixed sized stack. So in this case I have said the stack size is 5, and I'm checking if the top equals 5, because if the top is equals to 5, then the stack is full. So I print if the top is equals to 5, that the stack is full, else I'm adding the data from the main program into the stack and I'm incrementing the top. When I'm popping from a stack, okay, how it works is I check if the stack is empty. If it's empty, I'm displaying the stack is empty, else I'm decrementing the top and I'm removing the value from the stack top and initializing that index to 0. Alright, if you take a look on the left, there is a simple stack, as you can see, of 5 element size stack. So now if I were to push in values 5, 4, 3 and 3, 2 and 1, so how would that work? So first I'll be adding 5, yeah? So 5 will be added from here and will be stored at this point, and this point currently, as there are no values, will be called top. So 5 will be stored here, and when 5 is stored, top is incremented and will point to the index 1. And when you add 3 will be stored here. 3 will be stored here and top will increase once again. Then 4, top is increased, then 1, 2, then 1, top is increased. Now if I were to try to add more values in the fixed array stack, fixed size stack, it will give me an error message saying the stack is full. So you can see that I'm printing out an error message saying stack is full when the top is equals to 5. But there is another way where you can use dynamic stack, where the stack size increases according to the size, the number of elements you're adding. Alright, let's just quickly run the stack method, the stack the pop and the push in the main class, and see how it works. Alright, so now I am again initializing object called stack of the stack class, and I'm checking if the stack is empty and the stack size, and I'm pushing in 5 elements, 5, 4, 3, 2, 1, and I'm displaying it, and I'm checking if the stack is empty and stack is full, and I'm popping 2 elements out. Okay, let's run this code and see how it works. Alright. As you can see, initially your stack will be empty. Alright, so since the stack is empty initially, it will say stack is empty. So yes, it's true, stack is empty. Then the size, there are no elements in the stack, so it will say stack is 0, size is 0. And then we are adding 5, 4, 3, 2, 1. So 5, 4, 3, 2 and 1 are added, and top is 5 in this case. And then what we do, we are removing 2 elements, popping out 2 elements from the stack. So you can see we are popping out 2 elements from the stack. So when you pop out 2 elements from the stack, unlike in Q where the first element that added will be removed, in this case the first 2 elements from the start, from the top. So 1 will be removed out first and initialized to 0, and then 2 will be removed out and initialized to 0. Alright, and you can see 5, 4, 3 is there, but the rest is removed as those were added last. Alright, that's it for stacks. Now let's take a look at dynamic stacks. Dynamic stacks is basically the same thing as stack, but it has the same methods and all of that. The only problem is, or the only good thing about using a dynamic array is, dynamic stack is, even if the stack is full, you can keep adding data as it will automatically expand the size of the stack. So the code is basically the same. You have the push, but instead of saying, printing out an error message saying the stack is full, we are calling a method called expand. In the method expand, we are initializing the stack value, the size we are storing into a variable called length, and we are creating a new stack with the capacity times 2. So in this case I have said capacity equals 2. So when I say this, it will be capacity times 2. And then I'm using this method, this inbuilt method called array copy. What that does is it copies data from one array into another array. So first I say the array which I want to copy, then from which point and into which array, and from starting from which point and the size of the array. And since I'll be using stack all over the place, I just store the new stack inside the variable stack, and I increase this capacity by 2. And even in pop we have pop. What we do is, after we remove the data, we have to shrink. So let's just say that we have an stack size of 8, and when there are 4 elements remaining, you shrink the size of the array stack back to 4, so that it will look more nicer and it will be more efficient. So all you have to do is, let's just make a quick change by saying this as the dynamic stack, and if you run this code, you should be able to see how it works. Okay, as you can see, there's no changes, but the change occurs when we try to add more data. So let us try adding after pop. Let's just copy the entire thing. So let's just say we want to add the exact same thing. Alright, so in the earlier code it will display an array message saying that the stack is full, but in this case, if you run it, you could see that the the stack size is being increased. So let's just copy it again and paste it to make it more clearer. Right, so if you were to run this again, as you can see, initially the stack size is 4, then it keeps on increasing the stack size depending on the number of elements you're adding. Alright, that's it for dynamic stacks. Hope you all understood. Thank you.